Hello friends, in this session we will be talking about distribution factor for synchronous motor. Let's begin. So here we have talked about KD, right? Distribution factor. KD1 rather, right? Which was what? Sin Q gamma by 2 upon Q sin gamma by 2. Is it right? Yes. Now, previously, what did I say? I said that this is KD which is there. It is for induced EMF. Of course, it is induced EMF, right? Because it is a factor by which net RMS value of induced voltage is reduced. It is a factor, right? So, it is going to be for induced EMF only. But here is the thing. See, you may say that, sir, induced EMF is there in generator. Yes, it is there. Is it there in motor? Yes, it is there, right? But if I say now that this particular, what do you say, distribution factor KD, this is only valid for generator, then will it be true? Will it be true? See here. We need to understand one thing. What is KD? KD is a factor, or we can say this one, KD, distribution factor. It is a factor by which net induced voltage, or you can say net RMS, is reduced because of distribution of winding. Right? Yes, 100%, sir. This is what we discussed earlier, right? But now see here. Here, if you see, we are only talking about what? Net induced RMS voltage, right? Net induced RMS voltage. That is the reason that particular equation which we had. What was that equation? KD equal to sin Q gamma by 2 upon Q sin gamma by 2. This is only valid for generator. Now, what will happen in case of motor, sir? Let us see. See here. In case of motor, if you see, first of all, let us understand why that particular equation is not valid for motor. Let us see that. See here. When we talk about motor, do you remember the fact that motor is same as what? Transformer primary. It is same as transformer primary, right? 100%, right? And then we had discussed some assumptions for them. Assumptions for them. What were they? Assumptions were that transformer primaries and motor inputs will be connected to ideal voltage sources, which means if you think of transformer here, if for example this is a transformer, right? This is a transformer. So if your supply voltage is plus or minus 100 volts, right? Then what is going to happen? 100 volts here, so 100 volts will appear here, right? So 100 volts here, 100 volts here, because of which 100 flux lines will be there. Already we have discussed in transformers, no need to describe again, right? Yes, 100%, sir. So now if you think of induced voltage here in case of transformer, if you think of, it is equal to the supply voltage, right? Why? Because it has to, no? Mod of V1 is equal to mod of V1 in case of transformers, right? So you please tell me, in case of motor, if you think of, just assume that Now just assume that this primary is nothing but motor, which is true, yes, because primary absorbs electrical power, right? So let me just assume that it is equal to motor. So now in a motor, if you see, if you apply 100 volts, then this EMF induced, or this EMF is also called as back EMF. This particular back EMF induced is, will it be decreased? No. Why? Because whether it is motor or it is transformer primary, we know that it has to be 100 volts, 100 volts, 100 plus lines. So in case of motor also, same thing has to be followed, because see here, basically what I want to say that in case of motor, if you think of induced voltage which is there, or we can say back EMF, induced voltage or back EMF or back EMF, magnitude is equal to supply voltage. Is equal to supply voltage, means my back EMF which is there, or we can say induced EMF, that will be dependent on supply voltage. Now if it is dependent on supply voltage, if you think of, by the way, when I am saying that it is equal, this is only for ideal machine case. This is for ideal machine. What happens in practicalities and all, we may see later. So whenever we think of induced voltage or this back EMF, if we think of, that will be completely dependent on supply voltage. Why? Because assumptions are what? That transformer primaries and motor inputs have to be connected to ideal voltage source. So if here it is going to be 100 volts, 100 volts, 100 volts, 100 flux lines will be there, right? Now see here, very important, very easy, very easy. So when I am saying that in case of motor, induced voltage will not change. I can say that in case of motor, if you see, since its input is connected to ideal voltage source from the assumptions video we have seen, so motor which is there, it will know, means the back EMF of motor, or we can say induced EMF, or we can say back EMF, will not change. Then what will change, sir? Induced voltage is not at all changing, right? Then what is going to change? Let us see. If induced voltage is not changing, then you may say, sir, there is no need to think of KD. We will simply ignore it. You cannot ignore. Why? Because stator of synchronous motor, same as a generator only, right? Right? So if you think of, because see, you need to understand this one thing. Stator which is there, stator of whether it is synchronous machine in the sense alternator as well as motor, or induction machine, generator or motor, same. All of these stator is going to be same. So you just see here, just focus here, which means what, we need to define something for this, right? But then before that we need to understand, if EMF is not changing, then what is the thing that is changing? Because of distribution. So because of distribution, if EMF is not changing, then MMF is changing, or rather we can say MMF is going to be reduced. How it is going to happen, we will see just now. We'll see, don't worry. Let us see that how MMF is going to be reduced in case of motor, means because of distribution. I am again repeating the statement. What is that? Because of distribution of winding, in case of motor, net MMF will be reduced. How it is reduced? Let us see that. For that, let me consider this is going to be case 1. In case 1, as usual, I will take concentric winding. Or I can say that all the conductors are in same slot. All conductors are in same slot. That is what I can say. Concentric winding, and let me consider two-pole machine only. Let us not go beyond that. Just for understanding purpose, it's okay, no problem. Anyways, concentric winding, let us think of. So, yes, let me have stator here. Let me have stator here. Now, let me have conductors. 3 conductors as right. 3 conductors as previous. Since it is a two-pole machine, we know that if this is A1, then diametrically opposite to that is going to be A1 dash. If this is A2, this is going to be A2 dash. If this is A3, this conductor A3, then here it is going to be A3 dash, right? Yes, 100%. So now just see here. Just see here. A1, A2, A3, A1 dash, A2 dash, A3 dash. Why? Because it is two poles, so they are going to be diametrically opposite. By the way, when I was speaking about MMF, I am not at all speaking about field MMF. I am speaking only about the MMF of stator. Only about MMF of stator, means MMF coming from the stator. So now let us see how that MMF is. See dear, see, very simple. If for example this is dot as usual and this is going to be cross. So how is the MMF for A1 and A1 dash? This way, because the axis is going to be same, right? This is going to be the axis. So how is the MMF for A1 and A1 dash? Here it is cross. So into the word, out of the word, MMF is this way. So this is going to be MMF of FA A dash. MMF of A dash, A1 A dash, rather A1 A1 dash, F A1 A1 dash. Now, let me think of A2 A2 dash. A2 is again going to be dot, right? Dot, and let me have this as cross. So what is going to happen? This is also cross dot. Again, same direction. So again I am going to have this as F A2 A2 dash, same direction, and MMF value also, if you think of, it has to be equal only, equal MMF only. Why? Because they are again series connected, so same current has to flow through them. Anyway, see here, let me think of A3 A3 dash, A3 A3 dash also. Let me consider dot here, let me consider cross here. So this is going to be cross, this is going to be dot, coming out like this. So this is going to be same F A3 A3 dash, right? Now you please tell me, can I represent the same thing this way? Since all the 3 MMFs produced by all the 3 turns, you can say A1 A1 dash, A2 A2 dash, A3 A3 dash, if you think of all the turns, if you think of MMF created is in the same direction. So what will be the net MMF? Net MMF will be F A1 A1 dash plus F A2 A2 dash plus F A3 A3 dash. Since all of them are in the same direction, I can also represent this as, in terms of phasor, this way. This is going to become F A1 A1 dash. Then this is going to become F A2 A2 dash. And then again, this is going to become F A3 A3 dash. I hope it is clear, right? A1 A1 dash, A2 A2 dash, A3 A3 dash. So this is going to be the resultant. And so how is the resultant? So how is the resultant, sir? Resultant is going to be this one. This complete, this one is going to be this way. FR is going to be the resultant MMF because of concentric winding. Now let us think of distributed winding. This was case 1. See here. Let me think of case 2. Case 2 in the sense distributed winding. Again, I am to take two-pole machine only, right? Now let me consider this as stator. Bullseye. This is going to be the stator. Right? This is going to be the stator. Now see here, very simple. Here, if I have A1 conductor here, then diametrically opposite to it, I am going to have A1 dash conductor, right? Similarly, if I have A2 here, then diametrically opposite to it, I am going to have A2 dash here. Similarly, if I have A3 here, then diametrically opposite to that, I am going to have A3 here, right? Now see here, very simple, don't think much. See, this axis of A1 and A1 dash is going to be this way, right? The axis in which A2 and A2 dash are placed is going to be this way, right? And axis of MMF of A3 and A3, I mean this one, they are going to be this way only. They are connected in this way only, right? Anyway, see here. If I think of MMF produced because of A1, A1 dash, then how it is going to be there? Let me consider dot current here and let me consider cross current here, right? The moment I have dot current here, cross current here, what is going to happen? This is cross and dot, which means this way. So net MMF of this one is going to be FA1, A1 dash, right? See, this is the axis, right? This is cross and this is dot. That is going to be the direction of MMF. Cross and dot. That is going to be direction of MMF. Now, let us consider MMF produced because of A2 and A2 dash. If you think of A2 is going to be this, A2 dash is going to be this way. So this is cross and that is dot, right? So A2, A2 dash is going to be this way. Cross dot that way. So MMF produced is going to be FA2, A2 dash, right, sir? Now next, let us think of A3, A3 dash. This is going to be A3 dash, by the way. Let me consider A3, A3 dash. If you think of, this is dot as usual, this is cross as usual. So what is going to happen? Cross dot is going to be that this way, cross dot this way. So MMF is going to be this way, which is what? F A3, A3 dash, right? These are nothing but the phasors. Now let me represent this one as horizontal. So this one will move up, this one will move up, which means let me consider F A3, A3 dash here like this, right? So now what is going to happen? FA2, A2 dash is going to move again further. Whatever angle this was like this, right? Let me just consider this way, because no problem, because why? Anti-clockwise direction. Phasors are always rotating in anti-clockwise direction, so there is no problem in it. So let me just consider this one. So above that is going to come, leading to that I will have FA1, A2, A2 dash, right? Now again furthermore leading to that I am going to have FA1, A1 dash, and lengths of all of them are going to be equal. Why? Because whatever maximum value will be here, same maximum value will be here, same maximum value will be here. Distribution is there, but what is going to happen? After some time, rotor will rotate this way, no? So whatever maximum value this one has, after some time, same maximum value red will have. After some time, same maximum value my blue will have. Anyway, see here. This is F3, A3. This is called as phasor. Phasors rotating in anti-clockwise direction. We know that, right? So if whatever it is, anyways, that is going to rotate. Now see here, very simple. Now let me represent this particular phasor diagram in terms of EMF polygon. We have already seen how to draw that. So This is going to be EMF polygon, right? Let me have this point O as usual. That was the point O. Now I can show this F3 A3 dash horizontal, right? So let me just show this horizontal this way. F A3 A3 dash is horizontal. Now this is going to be a bit slanted upwards, right? Bit upwards this way. So that I can show that F A2 A2 dash. So let me show F A2 A2 dash here. Right. Now this F A1 A1 dash is also again more. So this is going to be F A1 A1 dash, right? Now if you think of resultant is going to be what? F A3 A3 dash plus F A2 A2 dash plus this one. So resultant is going to be this way. Resultant, right? Now see here. Now see here, very important. If I say that this and this one are placed in adjacent slots, which means the angle, this and this angle is going to be what? Slot angle gamma, right? So what is going to happen here? For example, I have rotor here, N pole here, S pole here. For example, N pole here, S pole here, rotor. So if I have this rotor, what is going to happen? If it is at A2, for example, N is here, S is here, what is going to happen? A2 will become positive maximum, A2 dash will become negative maximum. After some time, what is going to happen? After some time, in the sense, in space, after some angle called as gamma, which is slot angle, what is going to happen? A1 will become maximum and A2 dash will become maximum because N pole will get shifted here. I hope you are understanding my point. Anyway, see here. So if that is going to be the case, which means this is slot angle. So or if you think of this way, because it is motor, right? Because it is motor. So poles are not going to be rotated by ourselves. Poles will rotate automatically because of these fields. See here, very simple. What about MMF, let us say? Yes, see here. What has happened here? When it got shifted from here to here, in the sense by angle gamma, then what happened here? See here, MMF produced because of A1 A1 dash. A1 A1 dash is in this direction, and MMF produced by A2 A2 dash is in this direction, which means net MMF here produced will also change. Now see here, net MMF produced which is there, since this angle between this one, so this angle has to be gamma only, right? Why? Because MMF produced by A1 and A1 dash is going to be F A1 A1 dash, whereas MMF produced by A2 A2 dash is going to be this way. So if the angle between A1 and A2 is going to be gamma, then by the same angle, this has to be also shifted. So I may have, this is going to be angle gamma. This is going to be gamma angle, which is what? Between FA3 A3 dash and FA2 A2 dash. Similarly, FA2 A2 dash and this one, I am going to have same angle gamma. Now, if you remember, what was the things here? Is this same as the one we have discussed earlier? Right? See here, if you don't understand anything, let me take it this way. Let me just take these things out. See here, very simple. No need to take it out also. See. Very simple. See, this is origin. Let me just join this. Let me join this. Right? Now, see here. If this angle is gamma, this angle is gamma. We have discussed that if this angle is gamma, then this complete angle has to be gamma. Right? If this complete angle is gamma, which means this is also going to be gamma, this is also going to be gamma. So, this total is going to be how much? 3 gamma. This total angle is going to be 3 gamma, or we can say this way. Let me consider red here. This total angle is going to be 3 gamma. But what is 3 here? 3 is what? 3 is what? Slots available for distribution, which means 3 is going to be Q. Slots available for distribution. Nothing but slots per pole, per phase. I am repeating the things because it is very, very important. Once you have understood this, once for all, that's it. You have to only do these things once. After that, no need to revise this stuff again and again. Don't worry. See here. Now, let me drop a perpendicular here. Now see here. Let me call this as point A. This one as point B. This one as point C. This one as point D. And let me call this as perpendicular which I have dropped. Let me call this as point G. As usual, we are going to do the same derivation again. See here. Now, what is there? See here. Let me consider this one. Let me drop a perpendicular from here to here. Let me call this as F point. Now see here. What is this angle? This angle is nothing but half of 3 gamma. This 3 gamma, this particular 3 gamma means what? Q gamma only. Because this particular 3 is equal to Q only, right? So if you see here, this is same, Q gamma only. So if this whole angle is Q gamma, this half angle is going to be, how much? This half angle is going to be Q gamma by 2. Right? Now, if this is Q gamma by 2, again this is also going to be Q gamma by 2. What we need to do, just simply take, see here, whatever we have done previously, just this is revision, that's it. Sine Q gamma by 2. Let me take sine gamma by 2 first. What is sine gamma by 2? If you think of sine gamma by 2, gamma by 2 is where, sir? Gamma by 2 is where? This is going to be gamma. This whole thing was gamma. Blue angle was gamma. So what was there? This was going to be, if this whole thing is gamma, then this angle is going to be gamma by 2. Right? This angle is going to be gamma by 2. This angle is going to be gamma by 2, and this is right angle triangle, means what? Opposite upon hypotenuse. What is opposite? AG upon OA. Opposite upon hypotenuse, right? This angle, this AOG, angle AOG is what? Gamma by 2, which means opposite to that is going to be what? AG. Hypotenuse is OA, so it is going to be AG upon OA, or we can say AO. Anyways, doesn't matter. This is going to be sine gamma by 2. Now, let us think of, what is that? Let us think of sine Q gamma by 2. What is that? Sine Q gamma by 2, if you think of, this is going to be Q gamma by 2, or we can say this is going to be Q gamma by 2. What? Angle AOF. Angle AOF is what? Q gamma by 2. Now, let me apply sine Q gamma by 2. Sine Q gamma by 2 in the sense, opposite is AF. AF upon OA. This is going to be AF upon OA. Now, very simple. Can I say that from here I can write, therefore, AG is equal to, OA goes there, OA into sine gamma by 2. Right? And if I think of here, what is going to be there? AF. AF is going to be how much? OA goes there, OA into sine what? Q gamma by 2. Don't worry much. See here. Now, what I am saying here, what is KD? What is KD? KD is going to be what? Net MMF. Net MMF produced because of distribution divided by net MMF. This time it is going to be MMF because it is motor, right? So this is going to be net MMF produced because of, you can say, with distribution, and net MMF produced without distribution. Net MMF produced with distribution, net MMF produced without distribution. So if you think of what is net MMF produced without distribution, if you think of, yes, now see here, this is going to be FA1 A1 dash, FA2 A2 dash, FA3 A3 dash. This is what without distribution. So without distribution, if you think of, net FR is going to be what? Q times, we can say FA1 dash, FA1 A1 dash, right? Means, see, it is actually going to be 3 times, right? It is actually going to be 3 times, but we know that 3 is our lucky number and 3 indicates Q in our case, which is nothing but slots per pole per phase, and it means that number of slots available, which is not there, right? So let me just take it 3 as Q. That's it. No problem. Now see here. Let this be called as A, or you can say let this be called as, what do you say? If you think of FA1 A1 dash here, FA1 A1 dash here, it was going to be OD. I mean to say it was going to be CD, for example. Now let me just take it because all are equal only, end of the day. So let me just consider this as A and this as B, C and this as D. Now you please tell me, since AB is equal to BC is equal to CD, right? All are going to be equal. So the moment all are going to be equal, FAA dash, I will replace it by, let us say, AD, AB. And we know that AB is same as CD only. So I can also replace it by CD. There is no problem. Anyway, see here. So that is going to be Q net MMF produced without distribution is Q times AB, right? And if you think of net MMF produced with distribution, which distribution is what, sir? Which distribution is this one, FR? Where is it one? Yes, this was FR. This was FR, right? This was FR. So this is FR. FR is what? 2 times AF, because perpendicular bisector. This is perpendicular bisector. So it is going to be, if you think of here, what is that? Net MMF induced because of this one is going to be AF, right? So it is going to be AF into 2. Basically this is AD, right? AD only. This is going to be AD. Resultant net MMF produced with distribution is going to be AD. So if it is AD, then what is going to happen? See, what is AD? AD, if you see, AD is going to be what? AD is going to be 2 times AF. Why? Because perpendicular bisector. So it is going to be 2 times AF, right? Whereas if you think of AB, we want AB, right? This is AB, this is AB. AB is what? 2 times AG. AB is going to be 2 times AG. So let me just consider it as 2 times AG. Right, now just replace, it is a very small derivation, just replace AG here, AF here, which means what is going to happen here? See, KD, if you think of, KD is going to be what? 2 times AF, 2 times AF in the sense, 2 times AF is this, which means AF is replaced by OA sin Q gamma, OA sin Q gamma by 2. Whereas if we think of 2 times Ag, then 2 times Ag. Ag is what? OA sine gamma by 2. So this is going to be OA sine gamma by 2. But here one thing you just left. What is that thing? Q. Here we have Q also, right? So Q also will come. Now 2 gets cancelled, OA gets cancelled. What do you get here? You got KD equal to sine Q gamma by 2 divided by sine gamma by 2. Q sine gamma by 2. Now, is it the same equation? Yes, 100%. It is the same equation as previous one. But now what has happened? Definition has got changed. What is that? In this case, if you see, in case of motor, in motor, if you see, definition, just change the definition. In motor, KD is a factor by which net MMF is reduced because of distribution. I hope you are getting the point. So this is going to be KD for motor. Equations and all, everything is same. Why? Because we have understood it, right? Equations and all, everything same as induced case only. Everything is same. Just what is that? Here I will have net MMF to be reduced. Why? Because motor is supplied with ideal voltage source, and another thing was what? Ideal voltage source, motor, which means what? Back EMF of motor will be dependent on the supply voltage only. Whereas in case of generator it is not so. So in case of generator we can make point. This is motor. In case of generator, this is going to be for generator. So you can make note of this. You can make note of this already. You must have this. And this one. And make a note of this one. In case of motor, it is going to be net MMF reduced, and in case of generator, it is going to be net RMS value of the voltage reduced. Thank you.